So questions from lesson 3. Any of you want me to go over? Lesson 3 was page 19, 20, 21. Devin, what number? It's interesting how I'm kind of paused here. Now, D and E, I'm actually going to end up nuking, but I'll talk about them. But I think they're a little bit beyond what I was going for. But anybody number 4, or do you guys all get number 4? In the last class, everyone's like, okay. 4 I kind of like, but I don't like as much as number 5. 5 I like a little bit more. What we wanted you to realize last class, Jordan, was that unlike Math 10, when slope was rise over run, now we're also saying slope is a rate of change. It means something if I'm actually giving you data. If you have 2 points, if you calculate the slope between them by going rise over 1 or y2 minus y1 over x2 minus x1 equals the slope, that means something important. So, number 4. A large city with a bus transit system added a new rail transit in 2006. Blah, 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 blah. Here's what I think we're saying. In 2006, there were that many. In 2011, there were that many. How many years elapsed between 2006 and 2011? 5? Yes? If I want to find out the average rate of change, I think per year, it's over 5 years. And how many did we lose? Well, we started out with 22,380,025, and we ended up with 1,872,3,235, a difference of 365,6790. 3656790, and I'll put a negative because technically we lost numbers. We're smaller later on. If I want the average rate of change, it's going to be this divided by 5. We lost 731,358 riders. We lost 731,358 riders per year. Here's what I don't like about this question. So here's what it's saying. You opened up a SkyTrain and you had fewer bus riders over 5 years. Does that mean they all moved to the SkyTrain? Not necessarily. Some could have bought cars, right? Some could have moved out of town, right? Oh, and appropriate units. Riders per year. I think this 5 is in years, and I think this number is the number of riders. I don't think that's a very, very clear example of what we were getting at. Part B says, does this rate of change indicate conclusively that city railway transit is being used more often in 2011? No, because you can't assume that all the people that are no longer riding the bus are now automatically riding the train. Probably some more. You can't assume that they all are. So whoever asked me number 4, does that make sense? Okay. Number 5. I'll do A, B, and C. I'll talk about D and E. Who asked me number 5? Jordan, you did. So it says Donna is blah, blah, blah. Here's what I notice. They want me to plot the ordered pairs. They want me to plot 2 points. What's on the x-axis here? Read the question very carefully. What's the largest number of sales that this question mentions? I'm going to put that way over here because I want my graph to be nice and spread out. Is that okay? What's the smallest number of sales this question talks about? I'm going to put that right here, 9,350. Now, that's a dumb scale because right now you're saying, Mr. Dueck, if that's 10,000, shouldn't 9,000 be right about there? I'm not interested in being accurate. Instead, Emily, I want lots of room so I can figure out what the heck's going on. Okay? I'm doing a sketch. There's no grids here, so I don't need to try counting. On the y-axis, they want me to graph earnings. What's the most number of earnings that appears? I'll put that way up here. And 2,460, does that go with the 10,500 or with the 9,350? I'll signify that by saying, hey, that's a point right there where they cross. Is that all right? What's the next smallest number of earnings they gave me? And again, technically I should put that just below 2,460, but I want to stretch this out. I'm going to put it way down here, 2,322, and that, I believe, Jordan, goes with that one there. Because you know what part B wants me to find? This slope, which I'm going to argue is the rise over the run. How can I calculate my rise from those numbers? Like 2,000. I don't think I'm going to divide. I think subtract. I think you thought it right and said it wrong. Okay? And by the way, that's also why I drew this so big so I could see it clearly. I mean, technically, Jordan, this point should actually, if we went to scale, be like right there. But can you imagine doing rise over run for such a short line, trying to write stuff on it? Forget it. So what's the rise? What is 2,460 minus 2,322? 138. Negative or positive? Look at my slope. Is my slope uphill or downhill? It's going to be positive. And that's how much money earned per selling. What's my run? This minus that 1,150? Double check my math. Yeah? As a decimal, what is that? Oh, so $0.12 earned for every dollar sold. What that really is, just hang on, Marcus, what that really is a commission, and I can even tell you what percent for commission is. 12%. See it there? That's really what this slope is telling you. So part C, when it says explain what the slope of this graph represents, I think it represents she earns 12 cents for every buck she sells. She earns $0.12, which is 12 cents for every buck she sells. Marcus, you had a question? Great question. Marcus said, since it's slope, can we leave it as 3 over 25? I wouldn't take marks off. I glanced at this, and because it was in dollars, do I leave dollars in fractions, or with dollars do I generally... There's your time off. Or with dollars, do I generally go... You awake now? Got your attention? Got a little adrenaline rush? Woohoo! With dollars, I almost always go to 2 decimal places. So that's... To me, it would make more sense. That answer makes more... 12 cents a dollar makes way more sense to me. No pun intended, and I use the word cents in there like 3 times with a different meaning. Is that okay? So part B, explain what the slope of the graph represents. It's her commission. 12% commission if I do my math 8. Now, part D and E. Devin, her base salary is how much she earns if she sells nothing. That would be the y-intercept if you extended the line. And we could calculate that. I'm going to say, forget it for now. And then E, once we have the equation, this is actually some Physics 11, once you have the equation, if you plug that in for the amount of sales, you can calculate the earnings by using y equals mx plus b. I'm not going to worry about that, so I'm actually going to do that in that. Okay? Any others? No others? So, lesson 4 says this, scale factors and perimeter. How many of you have ever flown on an airplane? Have you ever asked yourself, let's pick a specific destination, a popular one, Hawaii. Have you ever wondered, look, instead of doing like 10 flights to Hawaii a day, why doesn't some airline just build an airplane that holds 5,000 people and they can do 1 flight? Not a helicopter. Thank you. Hang on a second. We'll just pause for a second here. I don't know if you ever wondered, why don't they just build a plane that holds 5,000 people and do one flight? Because you wouldn't have to worry, like you'd be using only one runway, you'd be able to do it with fewer crew. It wouldn't be as big an issue as the way they do it now. And the answer is, we can't simply scale up things. Things don't scale up nicely. What do you mean? You can't just triple the size of an airplane, make everything 3 times bigger, and expect that it'll work and fly. Or, the flip side of that is almost every horror movie that has ever been made, all the classic horror movies from the 50s and 60s in particular. Put your pencils down, look up. This is from the 50s. This is what movie trailers used to be like.
Scientists agree that unless something is done and done quickly, man, the dominant species of life on Earth, will be extinct within a year. The safety of the entire city depends on their full cooperation with the military authorities. Yes, cities, nations, even civilization itself, threatened with annihilation because in one moment of history-making violence, nature, mad, rampant, wrought its most awesome creation. But born in that swirling inferno of radioactive dust were things so horrible, terrifying, so hideous. There is no word to describe them.
So a classic horror movie from the 50s called Them. What are them, I wonder? Let's find out.
We were witnesses to a biblical prophecy come true, and there shall be destruction and darkness cometh with creation, and the beasts will reign over the earth.
Yes, the earth, the skies above and the seas below, infested.
So what are them? Yeah. No, not ants. Come on. Huh? Okay, giant ants. Oh, it's a classic horror movie. Or the one many of you may have seen, which is kind of a more comedy version of it, is this one. I don't know if you ever asked yourself, like, in your dreams or as you're wondering about the world, is it possible for somehow radioactivity to make a spider 3 times as big? You've seen movies that have giant spiders, there have been dozens of those made. Can they make a spider the size of this room? Can you simply make things 3 times or 4 times bigger and expect everything to work? Now what we call that is, can you scale things up? Or, in the case of Honey, I Shrunk the Kids, can you scale things down and expect things to work? What we're going to be looking at over the next few lessons is the mathematical relationship between scaling an object and what happens to its perimeter, its area, its surface area, and its volume. And today we're looking at scaling and perimeter. It says this: rectangles B, C, and D are all similar to rectangle A. Now the word similar has a very specific meaning in mathematics. The word similar means same shape. And I don't just mean same shape like, oh, it's also a rectangle. This, even though it's a rectangle, if I could draw properly, is not similar. You understand what I mean by same shape? And you can prove it mathematically. What I'd like you to do is take about 30 seconds right now It says, measure in centimeters and complete the following. I'd like you to measure the width of A, the height of A, the width of B, the height of B. Measure the length and width of all 4 rectangles and just write them on there really, really quickly. That's why you have a ruler. And it's kind of fun to measure things. It's like, well, no, it's not. Okay. You have to go? Oh, I thought you were packing up. Marcus, the lesson will be online, by the way. I don't know how far I'll get, though. By the way, I can't do it here because my computer screen has a different scaling factor than your textbook. Certainly, if I tried measuring here, I'd be getting that rectangle A was 21 centimeters. I don't think it's 21 centimeters in your book. Joe, what'd you get for this length right here? 3? How about here? 2? Now, what'd you get for B? What'd you guys get for length B? 6? Now, if these are truly similar, I noticed that 3 got doubled. I'm willing to bet this is 4, that got doubled. Is it 4? Okay, they're in scale. What'd you get for this particular length here, length C? Sorry? 4.5. Okay. If I go 4.5 divided by 3, because these two sides go together, it looks like I multiplied the 3 by 1.5. I'll bet you if I go 2 times 1.5, did you find that this side here was 3 long? Measure it. Is it? Yeah? What'd you find for this length here, length D? 1.5? How do they turn a 3 into a 1.5? What's the scale factor here? We would say there was a reduction by 50%. So I'm pretty sure this is 1. Yes? Lots of patterns here, Sam. You'll notice, for example, that if I go this side, long side divided by short side, long side divided by short side, I get 1.5. If I go long side divided by short side in any one of these, I get 1.5. They have the same ratio between the sides. That's another way you can check that they're similar. So here's what it's saying. It says, measure in centimeters and then complete the following, and it wants us to make a conclusion. I'm going to jump straight down to part 2A. It says the width of B is how many times the length of A. The width of B is how many times the length of A? 2. And the length of B is also 2 times the length of A. We would say that the scale factor here is 1 to 2. And we can write it as a ratio, Emily, or you can write it as a fraction. I prefer to write it as a ratio, because to me, what you're saying is every 1 centimeter became 2 centimeters later on. What about between A and C? What was the scale factor here? Well, the scale factor here was when we went this divided by that. You remember what decimal we got? Okay, the scale factor, now you could write this as 1 to 1.5, but that's got yucky decimals. We probably wouldn't write it that way. We would probably write it as, can anybody think? 2 to 3. How did I get that, Jordan? I doubled that to get rid of the decimal, did the same thing here. The scale factor there is 2 to 3. Every 2 centimeters became 3 centimeters in the new one. D. Here, instead of going from a scale factor of 1 to 2, instead of every 1 centimeter becoming 2 centimeters, I think every 1 centimeter became a half a centimeter. Except we don't like decimals. Instead of writing 1 to 0.5, how do you think we'd write that ratio? Take a guess. I heard it. 2 to 1. Here, 1 to 2, we're getting twice as big. Here, 2 to 1, we're getting half as big. Big deal. Well, actually, any of you that are techie, you sort of do some of this whenever you're adjusting your computer screen's resolution to match whatever input is going on. Or even the projector behind me, it's got a scale factor of about 1 to 10. 1 centimeter on this page becomes almost 10 centimeters behind me. And that's how you guys are able to see. Yeah. It wouldn't be wrong, just like it's not wrong to walk around with something hanging from your nose. Nothing wrong with that. But if you want friends, you'll wipe your nose. If you want math friends, you'll write your ratio as a non-decimal. And doesn't everybody want math friends? I'd take both. Now the risk would be this: if I gave you a multiple choice question, I wouldn't have that as an answer to pick from. I'd have that as an answer to pick from. I expect you to be able to do the conversion. Usually they'll be fairly easy ratios. It'll either be double it or triple it, and you'll be fine. Okay? Page 26. Turn the page. Here is a summary of what I've just said, but Sam, here's the vocabulary words. So, a linear scale factor describes the enlargement or the reduction of a length. You can either describe it as a ratio or as a rational number, or you can describe it as a percent. So the linear scale factor from B to A is 2 to 1, or 2, or 200%. Now back here, I wrote the scale factor from A to B is 1 to 2, from B to A, 2 to 1. And more terms, if the scale factor is greater than 1, we call that an enlargement. This projector enlarges the image so you guys can see at the back of the room. If the scale factor is between 0 and 1, a decimal, it describes a reduction. Yep. Okay. Cameras reduce images. When you take a landscape photo, click, it reduces it to about yay. What we want to ask ourselves is a very simple question. If I double the length and double the width, what happens to the perimeter? Is it doubled? Or maybe because you're doubling and doubling, is it 4 times as big because there's 2 twos? Or maybe something else is going on, or maybe there is no relationship. So here's how we're going to test it. We have, count them, 4 circles, 4 circles right here. And what it would like you to do is it would like you to measure the radius of each one of these circles. Now the radius is from the center to the edge, from the center to the edge, from the center to the edge, from the center to the edge. Really quickly with your ruler, measure the radius, please. What's the radius of circle A, Jordan? 2 centimeters? Circle B? 4 centimeters? Circle C? 3 centimeters? And circle D, I'm going to guess, is 1 centimeter? On my screen, it looks totally different. This looks like about 1.5 centimeters. This looks like 5. Anyways. Now, we want to look at the perimeter. First of all, what's the linear scale factor of circle B from circle A? Let's see. Circle A is 2, circle B is 4. That's a 1 to 2 enlargement. It's a 1 to 2 scale factor. Circle C to circle A, sorry, circle A to circle C is 2 becomes 3. And going in the other direction, every 2 became 1 if I'm going from A to D. And yes, Danielle, you could say 1 to 0.5. But to me, 2 to 1 ratio is way easier to do math with, too. Circle B, the radius is twice as big. I wonder if the perimeter is twice as big. Circle C, The radius has a 2 to 3 ratio. I wonder if the perimeter has a 2 to 3 ratio. Circle D, the radius is half as big. I wonder if the perimeter is half as big. And if that's the case, that's a fairly easy mathematical relationship to remember. Well, recall the perimeter of a circle is called the circumference. And the circumference can be calculated as 2 pi r. It's sitting right there. So it wants us to calculate the circumference, but to avoid getting yucky decimals so we can spot the pattern, instead of multiplying by pi, 3.1415926535897932, instead of multiplying by that, we're just going to leave a pi in our answer. We're going to leave our answer in terms of pi so it's easier to spot the pattern. I'll show you what I mean. The circle A has a circumference of 2 times pi times the radius. What was the radius of circle A? 2. You know what 2 times pi times 2 is? It's 4 pi. What was the radius of circle B? 4. The circumference is going to be 2 times pi times 4, or if I simplify, 8 pi. 2 times 4 with a pi on it. The circumference of circle C is 2 times pi times 3, or 6 pi. The circumference, try that again. The circumference of circle D is 2 times pi times 1, or just plain old 2 pi. It says determine the perimeter scale factors by completing the following. If I take the circumference from B, 8 pi, and I divide it by the circumference from A, 4 pi, in lowest terms, you know what 8 pi over 4 pi is? The pi's cancel, and you get 2. In fact, the scale factor is 1 to 2. Now, that's the perimeter scale factor. What was the length linear scale factor? Also 1 to 2. It turns out, and I'm not going to do 2 and 3. It turns out when you're done yawning, Joe, that scale factors and perimeter are related in a 1-to-1 relationship. In other words, Emily, if you double the length and the width, you've doubled the perimeter. If you triple the length and the width, you know what you've done to the perimeter? Tripled it. If you divide the length and the width by 5, you've divided the perimeter by 5. So part 2 says, complete the following to investigate the relationship between linear scale factor and perimeter scale factor. Okay. If you have a 3 by 5 rectangle, first of all, we need to remember that the perimeter is 2 times L plus W, twice the length plus the width. It's 2L plus 2W, but it's easier to add length and width together and then times it by 2. What's 3 plus 5? 8 times 2, perimeter. If we apply a 2-to-1 or a doubling scale factor, instead of 3 by 5 will be 6 by 10. What's 6 plus 10? Times 2, 32. The scale factor for the perimeter is 2-to-1, or it's a scale factor of 2. Maybe this is too obvious. I can't tell whether you're lost or bored. Let's do another one really quickly. What's the perimeter of a 2 by 6 rectangle? What's 2 plus 6? Times 2. It's got a perimeter of 16. Now if I have a scale factor of 3, instead of 2 by 6, it's going to be 6 by 18. What would the perimeter of this be? What is 6 plus 18? 24 times 2. It's going to have a perimeter of 48 centimeters. Now, the scale factor was 3. The new perimeter is 48 divided by the original perimeter of 16. Does that also have a scale factor of 3? Yes. What if we had a 9 by 6 rectangle? What's the perimeter? What's 9 plus 6? 15 times 2? 30. if we have a 1 to 3 or a 1/3 reduction, instead of 9 by 6, if I reduce these by a factor of 1/3, in other words, if I divide them by 3, I'm going to have 3 by 2. Yes? What's the perimeter of a 3 by 2 rectangle? 3 plus 2 is 5, times 2 is 10. What's the relationship between 30 and 10? The new perimeter is 10, the old perimeter is 30. We do have a 1/3 reduction. The last one's a bit trickier because it doesn't have ones in it. We have a 3 by 12 rectangle. What's 3 plus 12? 15 times 2. Boston, the original perimeter, is also 30. But my scale factor is 2 to 3. Every 2 centimeters becomes 3 centimeters. How the heck would I do that? Wow. Say that again. Turns out you want to divide it by 2 and multiply it by 3. Did you just come up with that on your own? You get a candy later on. I'm impressed. I was just sitting here, how am I going to get them to trickle their way to this? And you came up with it on your own. If I take this, divide it by 2 and times by 3, let's see if that works. 3 divided by 2 times 3, I get 4.5. I don't know. I'm going to write that down really small right now. By 12 divided by 2 times 3, 18. I don't know. Let's see. 4.5 plus 18. 4.5 plus 18 equals, times 2 equals. Is this a 2 to 3 relationship? Here's how you can find out. If I take the, make sure I get this right, Mr. Dueck. Boston, actually, I think we did this backwards. This is why I wrote this really small. I think instead of dividing by 2 and timesing by 3, I think we want to times by 2 and divide by 3. Now here's how I know. Look up. What did we do with this 30 to get a 10? I think we times by 1 and divide by 3. I think we times by the top and divide by the bottom. Fancy math time? Times by the numerator, divide by the denominator, times by the top, divide by the bottom. I think instead what I want is take this 3 times by 2, divide by 3, and that's a 2 to 3 relationship, a 2/3 reduction. It's going to be smaller. 2 by, take this 12 times by 2, divide by 3, and that's going to be a reduction. 2 by 8. It's 2/3 as big. What's the perimeter of a 2 by 8 rectangle? 10 times 2, 20. And here's how I can check that I'm right. If I write my new perimeter and I divide it by my old perimeter, what is that in lowest terms? 2/3. That's how I knew we'd done it wrong earlier, because when I did new divided by old, I wasn't getting 2/3, I was getting 3 over 2. And I said, we did it backwards. Part B says, compare the linear scale factors and perimeter scale factors and use these results to make the following statement true. What can you say about the linear scale factor and the perimeter scale factor? They are the same. Matches. Perimeter scale factor, matches, equals, is the same as linear scale factor. we are going to temporarily pause here. Part of your homework right now is number 1, 2, and 3.